Well, tonight we are going to shift our focus onto a topic that's kind of been simmering on the back burner for a while. We're going to shift it to the front of our minds tonight. Is trigonometry. We're specifically going to focus on exact value review. When you first look at this table, how confident do you feel filling in these values? First of all, if I gave you these degrees, could you convert them to radians? And then could you evaluate the sine of each angle, the cosine, and the tangent of each angle? So we're going to practice those a little bit. And then eventually transfer those into this unit circle and kind of do some quick review of that. And hopefully tomorrow, if we have time in class, we'll have some quick, fun competitions with how fast we can fill in this unit circle. All right, so let's set up a quick two-column table here. And as far as degrees go, if I started off with 30 degrees and I wanted to convert that to radians, well, really the game plan is we're going to multiply the given angle by pi over 180, and 30 pi divided by 180 reduces really nicely to pi over 6, and this becomes one of those angles that's so popular that you probably at some point, without even knowing it, will just memorize that 30 degrees is equivalent to pi over 6 radians. How about, what if I gave you 45 degrees and we followed that same process of multiplying by pi over 180? That would reduce itself to pi over 4 radians. Or what if I gave you 60 degrees and we multiplied that by pi over 180? That would reduce really nicely to pi over 3 radians. What else could we try? We could try 90 degrees, and that would reduce nicely to pi over 2 radians. And really, what's so nice is once you've gotten these 4 angles down pat, really every other angle in that unit circle is a multiple of one of these 4, and you could kind of build off of that and cheat a little bit. Now, as far as evaluating these different trig functions, and I've set up my table maybe just a little differently than you have in your notebook earlier this year, but if I want to evaluate the sine of 30 degrees, it's one of my favorite values. It's just a really clean 1/2. The sine of 45 degrees is going to be radical 2 over 2, and the sine of 60 degrees is going to be radical 3 over 2. So you'll notice a couple common themes here. Every one of these denominators is a 2. Okay, and really the numerators just increased by 1, and of course you put a square root over them, and of course you could put a square root over this guy, but the square root of 1 is still 1. Now when you get to cosine, all you got to do is really reverse the order of those values. The cosine of 30 is now radical 3 over 2, cosine of 45 is still radical 2 over 2, and the cosine of 60 is a clean 1/2. And when you get to tangent, all you've got to do is take, let's see, if you take your sine value and divide it by your cosine value, and of course dividing one fraction by another, is a quick review of, I like to use keep, change, flip, but ultimately what you're going to end up with here is 1 over radical 3, which when rationalized becomes radical 3 over 3, okay? Radical 2 over 2 divided by radical 2 over 2 makes 1, and radical 3 over 2 divided by 1/2 makes a clean radical 3. Now the other curveball they could throw at you is the reciprocal function, so we'll do a quick crash course there. The reciprocal of sine is going to be what we call the cosecant function, and we're just going to go ahead, and the cosecant of 30 is 2. Let's see, 2 divided by radical 2, which really becomes just radical 2 when rationalized, and then we're going to flip and rationalize to get 2 radical 3 over 3. Let's see. The reciprocal of cosine is going to be the secant function. And again, we're just going to flip and rationalize. Okay, so we just end up with radical 2 and a 2. And let's see if we can make ourselves a little bit of room here for tangent. His reciprocal function is the cotangent function. Let's see, we're going to flip it, but then we're also going to rationalize it. So it becomes 3 radical 3 over 3, which is just radical 3. Flipping a 1 is 1, and 1 over radical 3 becomes radical 3 over 3 when rationalized. Now if we did happen to go, because we're really speeding through these values as we think they're review, but if you want further explanation on any of these, I would be more than happy to kind of do that on the side if you got a free period tomorrow, and we can kind of do a deeper dive, slow down, and kind of get behind the scenes on those. All right, I'm going to do one family of angles here for you, and I think once we kind of do one family, you got a really good taste of how the others are going to go. So, for instance, I'm going to pick on this point right here, and the angle right there is 30 degrees. So I'm going to try to squeeze in a 30. Converting that to radians gives me pi over 6. Okay, and what do you need to know about the unit circle? Well, the point represented by x comma y is equivalent to the cosine of theta comma sine of theta. So in order to evaluate this x coordinate, all I'm going to do is evaluate the cosine of 30, which is radical 3 over 2. And then for the y coordinate, I'm going to evaluate the sine of 30, which gives me the 1/2. And then you could do the same thing for 45 degrees. You could do the same thing for 60 degrees. But I'm going to skip. I just said I was going to do one family. This reference angle is also 30. So this angle itself is 150. Now here's where you can really cheat here just a little bit. How many times bigger is 150 compared to 30? Okay, well it's 5 times bigger. So I'm going to multiply this angle by 5, and that's going to make 5 pi over 6. Okay, and then really the cosine of 5 pi over 6 is going to be the same as the cosine of pi over 6, except now I do have to negate it because I'm in the second quadrant. When I evaluate the sine of 5 pi over 6, that's going to stay positive 1/2. I don't have to negate that one because when you're in the second quadrant, who's positive? The sine of theta. And then who's negative? Well, cosine and tangent. So there's some other quick review. Let's see. We got a reference angle of 30, and 180 plus 30 makes 210. That's 7 times bigger than 30 degrees, so 7 pi over 6. And this time it's going to be negative radical 3 over 2 and negative 1/2 because both sine and cosine were negative in this quadrant. Here's another reference angle of 30. If I do 360 minus 30, that's going to make 330. Okay, that's 11 times bigger than pi over 6, so I'm going to go 11 pi over 6. And let's see, this time cosine is positive, but sine is going to be negative because of the quadrant I'm in. Again, we went through that really, really fast. Love to kind of slow down, and if the unit circle is your arch nemesis, we can definitely tap the brakes and go more detail tomorrow, maybe after class or during a free period. All right, just practicing these conversions from degrees to radians a little bit more. I'm going to show you two approaches. The first one is, if I kind of take a longer approach, take your 315, might as well just put it over 1, and then we're going to multiply that by, so whatever you're converting it to is the value that goes on top here. So we're going to go pi over 180. That makes 315 pi over 180. And if I want to reduce that, I'm going to divide this number and this number by 45. Which makes 7 pi over 4, okay? Now, this kind of the shorter cut is to say, okay, the reference angle to 315 is 45. And I've already memorized that 45 degrees is pi over 4, okay? And then I ask myself, well, how many times bigger is 315 compared to 45? Well, he's 7 times bigger, and you could test that out on your calculator by taking 315 and dividing it by 45, you get 7. So all I got to do is multiply this value by 7, and I could say, okay, I'll do it this way. 315 is equal to 7 pi over 4. Let's flip the script just a little bit. Let's say that I gave you a radian angle, and I want to convert it into degrees. So you take that radian angle, and this time we're converting it into degrees, so now the 180 goes on top and the pi goes on the bottom. And the first thing you'll notice before you actually multiply is that you can actually cancel out the pi's, okay? And then we'll just go ahead and do 11 multiplied by 180 and then divide that product by 6, and you're going to come up with a really nice 330 degrees. Now the shortcut there is to say, okay, when I was given 11 pi over 6, the first thing I saw was pi over 6, and I know that that's equivalent to 30 degrees. So now just multiply 11 times 3, and then carry that 0 down, and you've got a winning answer. Now, if you've been confidently cruising through tonight, first of all, congratulations. But I think this is the one that's going to perk you up just a little bit. This is a question that is very highly missed on tests and quizzes whenever we see this question, because you'll notice what's happening is I've given you an angle. It's in radians, but it kind of goes under the radar because you'll notice there's no pi attached to this, which is uncommon, but it technically is legal. Not every radian angle has to be in terms of pi, but the process is still going to be the same. You just take the angle that was given to us. In this case, we'll just put it over 1. And the process is, if you're converting it to degrees, you're just going to multiply by 180 over pi. So unfortunately, there is not a pi here for us to cancel out with this pi. And that's okay. That's okay. That's not the end of the world. So if I go ahead and I multiply, 2 times 180 makes 360. 1 times pi makes pi. And now I can leave this answer in terms of pi, but most of the time they'll probably ask you to convert it to a decimal, and you just type it in your calculator and round appropriately. The first thing you'll notice is they're asking us to find the exact value of the cosine of 150, and the idea that it's exact value means my answer is probably going to be in terms of a radical, and therefore the calculator is not going to be very useful or productive here. So the first thing I try to do is draw a quick little sketch to see where exactly is 150, what quadrant is it in. So let's say if this is 90 degrees and this is 180 degrees, that means 150 is going to be about right here. And so if that angle is 150, how big is this slice right here, that reference angle? So I'm going to say my reference angle, and now you like to use an R with a little subscript of theta, is equal to 30 degrees. And all I did there was 180 minus 150. Okay, the next thing I want to ask myself is this answer going to be positive or negative? And I know all functions are positive in the first quadrant, sine is positive in the second, tangent's positive in the third, and cosine's positive in the fourth. So when we said that sine is positive in the second, what we're indirectly saying is that tangent and cosine are negative. So basically, let's say this. The cosine of 150 degrees is equivalent to negative cosine of 30 degrees. So my answer is negative radical 3 over 2. That is the exact value of the cosine of 150. We're going to close with this example here tonight and try to digest everything that we've seen. So let's see. I want to try to draw a picture. I want to try to draw a triangle, and I want you to think of the bow tie. Here's one triangle. Here's another triangle. Here's a third triangle. Here's a fourth triangle. The 4 triangles together make that bow tie. And what we're going to do is we're going to draw one of those triangles. Not all 4 of them, just one of them, based on the quadrant that we think this particular theta angle is in. So the first thing you'll notice is that the cosine of theta is negative, so that means I could be in quadrants 2 or quadrant 3, okay? They also said that tangent is greater than 0. That's their way of saying it's positive. That means that could be in 1 or 3. So what's in common? It must be in quadrant 3 because that's the only quadrant where cosine can be negative simultaneously to tangent being positive. So let's zoom in on quadrant 3. And what you know from the given information is that the adjacent side of the triangle has to be negative 3, okay? And the hypotenuse has to be 5. Therefore, the missing leg, by virtue of the Pythagorean theorem, is going to be 4, and I'm going to negate the 4 because we're going down below the x-axis. We starting at the origin, we went left, hence the 3 is negative, and then we went down, hence the 4 is negative. Your hypotenuse in our drawings will always be positive. Once you get this drawing, you're really golden, okay? So let's see what we got cooking here. We know that the sine of theta, let me mark that, theta is this rascal right there, okay, is going to be opposite over adjacent. His reciprocal, cosecant, is going to be negative 5/4, okay? Let's see, tangent is going to be opposite divided by adjacent, which turns out to be 4/3. Cotangent is going to be that reciprocal, so it's 3/4. And we were already given cosine, so to get secant, I'm just going to reciprocate that. And we could say secant of theta is negative 5/3. And that's all we got tonight. I know we went really fast through some of those. So like I said, I challenge you and encourage you to ask as many questions as you can tomorrow, and we'll try to put all the pieces together.